of the universe. He said the sun was the center, not the earth. Revolutionary. It shook astronomy to its core.
In Vesalius, he completely changed the study of human anatomy, dissecting human bodies, making detailed drawings that corrected centuries of wrong information. Pretty brave and controversial at the time.
Galileo's observations with the telescope were game changers too. He discovered Jupiter's moons, saw the phases of Venus, even sunspots. More proof for the heliocentric model. His experiments with falling objects also challenged those old Aristotelian beliefs about motion. Basically, he paved the way for modern physics.
And then there's Newton, of course. His laws of motion and universal gravitation, still cornerstones of physics today. He explained why things fall, how planets orbit, even the tides. A monumental achievement, uniting our understanding of the physical world.
It wasn't all just big names and theories, though. Even seemingly small innovations had a huge impact. Like Tartaglia, he introduced parentheses into mathematical equations in 1556.
Seems small, but parentheses changed how we write and understand complex math. Much clearer and easier to work with.
Exactly. And around 1620, the compound microscope pops up in Europe. Suddenly we can see the tiny structures of cells and microorganisms, like a whole new world opened up, revealing the hidden complexities of life.
A perfect example of how tech pushes scientific discovery. And this trend continued strong into the 18th and 19th centuries, with science branching out in exciting new directions, constantly expanding the boundaries of what we know.
As we move into the 18th and 19th centuries, science is just exploding. New fields popping up everywhere, scientists making crazy discoveries that change how we see the world.
A real intellectual whirlwind, huh? And Carl Linnaeus, he's a big one. In 1735, he comes up with this revolutionary system for classifying plants.
Oh yeah, brought some order to the chaos of plants, right? His framework is still used today.
It's wild how such a simple system can have such a lasting impact. Oh, and speaking of sparks and new ideas, this era sees the rise of electricity as a field of study.
You know, Ben Franklin's kite experiment, 1751, proving lightning is an electrical discharge. It caught everyone's imagination.
Everyone knows that story. And a few decades later, Alessandro Volta invents the battery, 1800, the first reliable source of continuous electric current.
A total game changer. The telegraph, the light bulb, so many things wouldn't exist without it. Volta took electricity from a curiosity to a force that shaped the modern world. And as the 19th century rolls on, other areas of science are also transforming.
We can't forget Darwin and Wallace, right? They independently developed the theory of evolution by natural selection, a huge challenge to the old beliefs about life and how species are related.
A paradigm shift in biology. It gave us a framework to understand the amazing diversity of life.
Darwin's On the Origin of Species, published in 1859, caused quite a stir. But the evidence was undeniable. Slowly, scientists started accepting the theory.
It changed how we see ourselves, our place in the natural world. It's huge. And at the same time, Mendel's doing his experiments with pea plants, laying the foundation for genetics.
His laws of inheritance, explaining how traits are passed down through generations.
Exactly. His work, kind of overlooked at the time, set the stage for modern genetics. So important for medicine, agriculture, biotechnology.
Incredible how it all connects. As the 19th century ends, we have James Clerk Maxwell. He comes up with the theory of electromagnetism, bringing together electricity, magnetism, and light.
His equations predicted electromagnetic waves, later confirmed by Hertz, paving the way for radio, TV, all kinds of things.
A triumph of theoretical physics. Then we have Mendeleev's periodic table in 1869, bringing order to the world of chemistry, arranging the elements in a way that revealed their relationships and predicted new ones.
Amazing, right? The human mind finding patterns and order in the complexity of nature. And as we move from the 19th to the 20th century, even more remarkable discoveries are just around the corner, discoveries that will change everything.
X-rays, discovered by Röntgen in 1895. And then Becquerel stumbles upon radioactivity in 1896. It's a whole new world.
The hidden structures of matter, the forces within the atom. A new era in physics, leading to huge advances in medicine, energy, and our understanding of reality itself. The 20th century brings an explosion of scientific discovery, a time of incredible innovation and progress.
So many things happening at once is hard to keep up. Breakthroughs that challenged old assumptions, reshaped our understanding of everything, amazing advancements, but also some serious challenges. It shows the power of the human mind, but also the responsibility that comes with it.
In medicine, the polio vaccine, developed by Salk in 1952, it's a victory for science.
Countless lives saved. A disease that terrified the world, eradicated. Science conquering even the toughest foes. And then, just a year later, in 1953, the structure of DNA is revealed.
The double helix. Watson, Crick, Franklin, Wilkins. It revolutionized our understanding of genetics, showed us how genetic information is stored and passed on.
The foundation for biotechnology, medicine, agriculture. We suddenly have the tools to understand and manipulate the very building blocks of life. It's a whole new chapter in human history.
And as we look deeper into the universe, more incredible discoveries. In 1962, the first cosmic X-ray source is detected. And then, in 1964, the cosmic microwave background radiation. Strong evidence for the Big Bang.
Wow, we could actually look back in time to the very beginning of the universe. It's humbling, seeing ourselves as part of this vast cosmic tapestry.
And in 1967, pulsars are discovered. These super dense, spinning neutron stars, remnants of supernova explosions, sending out beams of radio waves like cosmic lighthouses.
It's crazy. They thought it was aliens at first. It really pushed the boundaries of what we knew about stars and the extreme environments out there in space.
With all this new data coming in, scientists needed new tools to analyze it all. And that's how data-intensive science was born. Sanger's DNA sequencing method, developed in 1977, paved the way for modern genomics.
Now we could decipher the entire genetic blueprint of organisms, even humans.
Leading to personalized medicine, understanding the genetic basis of diseases, developing targeted therapies, the possibilities are endless.
And the discoveries just keep coming. High-temperature superconductivity in 1986. Yeah, imagine revolutionizing energy transmission, transportation, computing. And then in 1994, Andrew Wiles finally proves Fermat's last theorem, a math puzzle that had stumped everyone for centuries.
The power of human persistence. And in 1995, the first confirmed exoplanet orbiting a sun-like star. Other planetary systems out there. The possibility of other worlds with life.
It reignited our fascination with space, the dream of exploring beyond our solar system, and then a bombshell in 1998, the discovery of the accelerating expansion of the universe and dark energy.
It completely changed our understanding of cosmology, a mysterious force pushing the universe apart. Mind-blowing.
The 20th century, a wild ride of scientific discovery, leaving us with a sense of awe, but also a lot more questions to answer. It showed us the power of science to unlock the secrets of the universe and the importance of using that knowledge wisely.
As we enter the 21st century, science and technology are becoming even more intertwined, leading to a new era of discovery that's going to be even more transformative. As we dive deeper into the 21st century, one thing's for sure. The pace of scientific discovery is only picking up speed, and technology is playing a bigger role than ever.
It's like science and tech are becoming best buds, merging into this powerful force.
Exactly. Like we talked about earlier, the lines are getting blurry. It's a thrilling time to be in science, or even just fascinated by what the future holds.
Our sources really emphasize the incredible impact of AI in R&D across so many fields. Drug discovery, environmental research, healthcare, you name it. AI is revolutionizing how we approach scientific questions.
Take isomorphic labs, for instance. They're building on the success of AlphaFold to predict even more molecular structures. I mean, they're aiming to map out almost every molecule in the protein data bank, how they interact with other molecules, everything.
It's a huge undertaking, but think of the implications for drug development. Our understanding of biological processes could change drastically.
Absolutely. And then you have these large language models like ChatGPT being tested in healthcare, assisting with diagnoses, providing personalized health information. Who knows what else they'll be able to do? The potential is enormous.
It's incredible, but also a bit daunting. It raises all these questions about data accuracy, potential bias in the algorithms, the need for regulations. We can't just blindly embrace these powerful technologies without considering the ethical implications.
Couldn't agree more. Great power, great responsibility, right? We need to make sure AI is used for good, for everyone's benefit.
Well said. But let's shift gears a bit. Talk about some of the recent breakthroughs that have everyone buzzing. CRISPR, for example. This gene editing technology has gone from the lab to real-life treatments. The FDA approved Intellia Therapeutics CRISPR therapy for ATTR, a rare genetic disease.
And in the UK, they authorized Vertex and CRISPR Therapeutics Casgevy to treat sickle cell disease and beta thalassemia. It's a huge step forward for gene editing, offering so much hope for people with genetic conditions.
Truly remarkable. And what about space exploration? The Artemis program is aiming to put humans back on the moon, and maybe even Mars. And with the discovery of water on the sunny side of the moon in 2020, lunar exploration is looking more and more feasible.
It's not just about planting flags on other planets, though. Artemis is driving innovation in robotics, space medicine, materials science, you name it. The ripple effect of these advancements will touch so many fields.
It's inspiring to see how big goals, like returning to the moon, can push us forward in so many ways. And of course, the fight against cancer continues. We're seeing progress in immuno-oncology and the development of new therapies like TCO-01HER2, which shows promise in treating certain types of tumors.
Immuno-oncology is a rapidly evolving field, harnessing the body's own defenses to fight cancer. And as these new therapies emerge, we're getting closer to finding more effective and less toxic treatments for this devastating disease.
It's certainly encouraging. And there's been progress in treating neurodegenerative diseases too, like Alzheimer's, Parkinson's, and ALS. New drugs for Alzheimer's, non-invasive treatments for Parkinson's, and even gene mutations being discovered that could open up new therapeutic avenues for ALS.
The validation of alpha-synuclein as a biomarker for early Parkinson's diagnosis is a big deal. Earlier intervention could make a huge difference. These advancements give hope to so many people facing these incredibly difficult conditions.
It's amazing how science keeps pushing the boundaries, offering new hope where there was once none. But let's not forget, technology is a double-edged sword. We need to be mindful of its power. Use it responsibly.
You're right. Take the democratizing effect of AI in research. AI is giving more researchers access to sophisticated tools and techniques. Not just the big institutions anymore. It's leveling the playing field, potentially leading to a more diverse range of discoveries and innovations.
Imagine smaller organizations with limited resources suddenly having access to the same powerful tools as the big players. It could completely change the landscape of scientific discovery.
And then there are AI agents basically acting as research assistants. They can analyze data, generate hypotheses, even design experiments. It's not about replacing human scientists, but augmenting their abilities, speeding up the process.
Like having a tireless research partner working 24/7 to uncover new insights. The possibilities are mind-boggling.
Absolutely. And we're also seeing the rise of open data initiatives and collaborative platforms like Project Resilience. These initiatives use AI to connect researchers and data from around the world, fostering collaboration on big issues like climate change, education, and pandemic preparedness.
It's a beautiful example of technology breaking down barriers and promoting global collaboration. We need this kind of collective effort to tackle the complex challenges we face in the 21st century.
Absolutely. Now, looking ahead, there are some exciting trends emerging. Green chemistry is undergoing a transformation, with researchers developing better ways to predict the environmental impact of chemical processes. This is paving the way for a more sustainable approach to chemistry.
I'm really intrigued by companies like Metero. They're using industrial byproducts and waste to create eco-friendly alternatives to plastic. It's a fantastic example of how green chemistry can address real-world problems.
And in the world of energy storage, the search for alternatives to lithium and cobalt is driving some serious innovation in battery chemistry. We're seeing more lithium iron phosphate batteries, which don't rely on those scarce and expensive materials. Plus, researchers are exploring new chemistries using more sustainable elements like sodium, iron, and magnesium.
It's amazing how the need for sustainable solutions is fueling such creativity. And speaking of innovation, biomaterials are having a moment. We have Neuralink's brain-computer interface, which got FDA approval for human trials in 2023. Then there are bioresorbable electronic devices that dissolve harmlessly in the body after they've served their purpose.
Bioelectronic materials are blurring the line between biology and technology. It's like science fiction becoming reality.
And natural biomaterials like chitosan and silk are being used to create advanced materials. There's even an injectable hydrogel brain implant for treating Parkinson's disease. Nature is providing us with such versatile and adaptable materials.
For sure. And with specialized bioinks being developed, we're seeing incredible progress in 3D printing organs for transplantation and research. Imagine a future where we can print custom-designed organs on demand, reducing the need for organ donors and revolutionizing regenerative medicine.
It's mind-blowing. The potential is there. It's clear that we're living in an era of incredible scientific advancement, from the fundamental laws of physics to the complexities of DNA and the vastness of space. Science continues to push the boundaries of what we know and understand.
It's been an amazing journey through time, exploring the discoveries that shaped our world and continue to shape our future. And as technology becomes increasingly intertwined with science, the pace of discovery is only going to accelerate.
The possibilities seem limitless, but we must remember to wield this power responsibly. Science is a tool, and it's up to us to use it ethically for the benefit of all humankind.
Well said. It's been a fascinating and thought-provoking exploration of scientific discovery. Thank you for joining us on this journey.